Today is day 2 on using the discriminant to find the number of solutions. So let's take a look at different problems that we'll end up experiencing. First, before we do that, let's take a look at what the discriminant is. Again, it's this b squared minus 4ac. So it's just this little part of the quadratic formula. Remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So it looks at just this little portion here, because if this number is greater than 0, as this says right here, greater than 0, the equation has two answers because of the plus or minus sign. If it's equal to 0, there's only one answer. Only one answer because, again, of this plus or minus sign. It cancels out because if this is equal to 0, we don't have that plus or minus sign, so it's just negative b over 2a. If it is less than 0, we have no solutions, because if it's less than 0, you'll have a negative radicand, which means that you don't have any x-intercepts. So let's take a look at the problems. The directions on some of the problems will say find the number of real solutions of each equation by using this discriminant. So the first thing you want to make sure is that you always set equal to 0. Make sure it's set equal to 0, which it is, and then from there you can figure a, b, and c values. So we're just using the discriminant, the b squared, so 10 squared minus 4 times 3 times 6. Now one thing you should notice is that whenever a and c are the same sign, you're always going to have an odd number of negatives. And so here we're going to end up having to subtract. So if the 4 times the a times the b or c terms are bigger than 100, because 10 squared is 100, then it's going to be no solution. So you got to watch for that. 12 times by 6 gives me 72. So I see this is going to have a solution. This is going to have two solutions because this is a positive number. So here we end up with 28. This is greater than 0, so that means that we have two real solutions. Looking at the next one here, we've got a 10x squared plus 9x equals negative 2. So always move the terms over until it is in that descending order with everything set equal to 0. So now, again, it's important to put in descending order so you can figure out your a, your b, and your c terms easier. And so we just substitute those numbers in there. So we have 9 squared minus 4 times a, which is 10, c, which is 2. So you do some work there. We've got 81 minus, again, minus because a and c are the same sign. So we have 4 times 2 makes 40 times by, so 4 times 10 makes the 40, times by 2 makes 80. Oh, wow, it's real close. This is equal to 1, but still greater than 0, so there's two real solutions here. So let's take a look at the next one. This is asking us to find the number of x-intercepts of each of the functions. And so looking at this first one here, we have 9x squared minus 30x plus 25. So we're going to go ahead and use our discriminant. It's asking the same thing. When we try to find x-intercepts, we're always going to set y equal to 0. The same thing we had to do here. We had to set it equal to 0, set the equation equal to 0. So we're setting this y equal to 0, and then just pulling out our a, our b, and our c terms. And so here we have our negative 30 squared, and again, negative 30 squared is going to give us the same answer as positive 30 squared, minus 4 times a, which is 9, and c, which is 25. So this makes 900, and over here, 4 times 25 makes 100, times by 9 makes another 900. And so here we have to subtract, because a and c are the same sign, so that means we only have one negative, an odd number of negatives, which equals 0. So that means we have one real solution, or one real, well, I guess one x-intercept. So I'll write them both down there. One real solution, or one x-intercept. That's what they're asking for there. How many x-intercepts do we end up having? And there is our answer. Well, looking at this last one, again, we're going to set y equal to 0. So that becomes 0, and we pull out our a, our b, and our c terms. Watch. b is negative 1. You can always put a 1 in between a minus sign and a variable. So we do that work, negative 1 being squared, minus 4 times a, which is 3, and c, which is 5. So we end up with just, again, a and c are the same sign, so we have one negative. So every time so far we've subtracted. 1 squared is 1, minus 4 times 3 times 5 ends up giving us 60. So I end up with 1 minus 60, which is negative 59. So whenever this is a negative number, the discriminant's negative, that means we have no x-intercepts. It means that the graph, if we were to graph this, it just wouldn't cross the x-axis. So that's what that means, no x-intercepts. So those are some of the problems you'll see. You do have a word problem that asks us to use this discriminant to answer a question. So in the past, professional baseball was played at the Astrodome in Houston, Texas. The Astrodome has a maximum height of 63.4 meters. That's the height it is. The height in meters of a baseball, T, the height in meters of a baseball, T seconds after it is hit straight up into the air with a velocity of 30 meters per second is given by this equation right here. So notice that it's 1 meter off the ground. That's what this 1 represents. 30 is the initial velocity, and this has to do with the acceleration of gravity. And this is a little bit more precise than our -5 that we've used. Will a baseball hit straight up with the velocity hit the highest point of the Astrodome's roof? Use the discriminant to explain. Well, we know what the height is. The height is 63.4. So let's go ahead and substitute this height right there in to h, because h represents height. We're going to see if this formula will give us this answer. Will this ball end up just getting up to this height, or will it surpass this? We're going to find that out. So 63.4, putting that in for h. It's a height, so it definitely goes in for h. And then we've got negative 4.9 t squared plus 30t, and then the plus 1. Well, what we need to do from this point is move that 63.4. So remember, always set equal to 0 every time when you're using that quadratic formula, or the discriminant for that matter, because the discriminant is just a portion of that quadratic formula. So let's go ahead and rewrite what we've got. We now have negative 4.9 t squared plus 30t, and then it's a minus because I'm subtracting more than what I've started with here, 62.4. So what we're going to end up doing is using this discriminant, putting in our a value, which is here, b, which is 30, c is negative 62.4, and we're going to put that into our discriminant. So I'll do it right here. So we've got 30 squared minus 4 times a, which is negative 4.9, and then we have times by c, which is negative 62.4. And so we go ahead and do some math there. 30 squared I know is 900. Just got to multiply this out. But watch the signs. Again, a and c are the same sign. This time they're both negative, but we still have an odd number of negatives, so we're going to end up subtracting here. So let's go ahead and multiply out those numbers. We get 4 times 4.9 times by 62.4 equals, oh wow, this is quite a big number. We've got 1,223.04. And so we go ahead and do some work there. We've got subtract here, 900. When we subtract those two numbers, we end up with a negative value here. So this is going to end up equaling negative 323.04 meters. And so what this ends up meaning is that we are not going to get to that height because we've got a negative number here, and we can't have a negative number. So what this means is if we were to launch this thing into the air, it comes up, and we're trying to see, does it end up reaching that maximum height? Well, the maximum height was way up here. It's all the way up here maybe. So we'll call this 63.4. And it doesn't quite get there. The height is this parabola just doesn't quite make it up to that point, and that's why we have this negative value. So what we say is we have no solutions, and if we had a solution, if this were positive, then it would have cleared it and come back down, and it would have hit in two areas, and we would have two spots with where it was at 63.4 meters. And if we had just an equals 0, that means it just touched it and then came back down. So in this case, no solution. No, it will not reach. It will not reach 63.4 meters because the discriminant was negative. So we got a negative number when we use the discriminant, so it just won't end up making it there. So again, the key is you've got to take whatever the height they give you, and they're asking you, is it going to reach that height? You've got to put that into h and then set it equal to 0, then use the discriminant. If you get a negative number, no, it doesn't make it there. If you get a positive number, yes, it makes it there twice. It surpasses it and then comes back down and hits that same spot. And if you end up with 0, that means it just makes it up there. So again, make sure you substitute the value that you want to find the maximum height of in for h to see if it actually reaches that height or not. Good luck on tonight's homework.